All right. Welcome everyone to another episode of Deep Dive. Today, super special guest. We have Hyperlane with us today. So, are you're John, one of the founders?
I am John, one of the
Yes.
founders at Hyperlane. Um, Happy to give a little bit of background about myself, how I got
For
to where
sure.
we are
Yeah, go
today.
for it.
So I've been in crypto for about 5 years, rounding out to the day. So late 17 was when I got my start professionally. I'd been a bond trader at Morgan Stanley beforehand, which is just like
Sorry to hear.
obviously very different, very different. Yeah, me too. I needed coming out of school, I needed a place to earn a living to support my parents financially, and like Morgan Stanley was the best place that I could find. I went to school at Berkeley, and Berkeley was very like, we were square, so you could call it that. Like, if you were in the engineering department, you went to work at like a Google, and if you were not in the engineering department and you wanted to be like a high achiever, you went to work in one of two worlds. It was you either went to work for a Wall Street bank, mostly in the banking departments of those banks, like doing investment banking, or you went to one of the consulting companies. And for me, predictably, it fell between Bain, the consulting company, and Morgan Stanley to join as a trader. And I picked Morgan Stanley because they had people more like me who, I'm a big basketball nut. And one of the guys on the floor was like assistant manager at Duke. We got along a little bit better, and
You
probably
had like
for
a
the
little
best.
bromance going, and it was
Totally, yeah.
yeah.
Like if you're listening to this right now and you're interviewing for an investment bank, find someone who has similar interests. Because my first interview, we ended up talking basketball for 40 minutes. We talked about my time in the idea for 20 minutes, and we talked about like the actual job for 35 seconds. And I got the job, so it worked out.
All right.
Um, and then got into crypto through Morgan. Funny enough, through like they all made fun of me. I spent a year and a half being the crypto nut at Morgan Stanley, but it worked out because I developed this like persona. And when a longtime client was opening up a crypto or like a long hedge fund that was a longtime client of theirs, got into crypto, the guys over there were like, wait a second, we have this guy here. If you're really serious about this, you have to talk to him. And 2 weeks after meeting those guys, I started working there. And that was kind of like my big break into crypto. So I spent a couple years at this firm. And then since then, next position was I ran the investment team with my partner, Michael Jordan. That's his real name. He's an amazing dude. We ran the investment team at Galaxy, Michael Novograss's firm, if you're familiar with that.
Yep.
And that led me to starting Hyperlane about a year ago now. And I'm going to tell you guys all about it. That's why we're
Did you
here for
raise
this deep
money?
dive. We have. We did. It
So
was
I'm guessing
recently announced.
Galaxy gave you money, or
They were part
okay.
of the crew that gave us money. We were very fortunate. We were very
Yeah.
fortunate that the number of people wanted to first in place to give us, and that Galaxy was one of them. Right, like they like me well enough. They still liked me enough that they wanted to back my next initiative.
Yeah, so I mean,
Um,
Hyperlane, it's we'll get into it, but it's sort of it's sort of Oracle-like, but it's mainly focused on sort of cross-chain messaging protocol, right?
that's right.
How did you pick that problem to begin with? Was this like a personal problem you were having, or did somebody just be like, this would be a good one to tackle?
No, it was both a personal problem, but also one that just seemed like so intuitive. So I get really into crypto in 2016 when a friend tells me he's going to put all of his money. This guy's like 23-year-old and has made some cash, and he says, John, I'm gonna put all my money into Ethereum. And I'm like, okay, this is might be a good idea. This might be a terrible idea. Let's spend time looking into it. And from that weekend, that's it. My life was basically like my old life was basically over, and my crypto life started. It's funny too. Like my girlfriend at the time was like, "What the hell happened? Like you came back to like a day and a half later, you're like a different person." And really, like my entire life course changed because of a buddy is like, "I'm going to put all my money into crypto." And from that point, like learning about these really cool internet computers, and then later on learning that they can't talk to each other. Well, they can't really talk to anything. They don't know anything about information that's not endemic to them. Uh, and so not knowing enough, right? Like not having any technical understanding of how these things work at the time. You're like, oh, next year they'll figure it out. Like this is gonna be a solved problem. And like next year rolls around, and suddenly there's like there's both same year, the Cosmos and the Polkadot, the ICOs. I don't know if that's a dirty word now, but that like I was like, okay, people are working on this. Cool, we're fine. And a few
Yeah.
months after that, I get into crypto and like, okay, it seems like it's gonna happen any year now. And it felt like for 5 years we've been a year away from being a year away. And so, as an investor, it's a problem I really, really cared about and was tried to stay very knowledgeable of. So we spent a lot of time within the Cosmos ecosystem learning about IBC. There's one good thing that Ripple did. It funded support for this thing called Interledger. Almost no one remembers Interledger, but it was like one of the original interoperability protocols. Um, and then later on, keeping abreast with things like Axelar and new innovations there. So I've been very, very interested in the category. And then personally, as a very heavy crypto user, you start seeing like interoperability come up. And it always came about like with the user interacting with infrastructure. Uh, it was we had as users a desire to move to other chains because we wanted to get to some interesting app on those chains. But no one was making our life easier. It was like, hey, jump through all these hoops, connect to these apps. And suddenly like apps start to realize, people want to be on that other chain too. I'm gonna deploy my app on that other chain. And then you get things like sushi, deploying on multiple chains. But the experience of using it could not be worse because it wasn't the case where you had sushi as an independent, like as as a unified app that happens to be on different chains. You basically had n many sushis, where n is the number of chains that they decided to deploy on. Outside of sharing the brand, sharing the front end, some familiarity. If I'd go into the documentation and get it, like they all work the same, but nothing about them is shared. Sushi on Arbitrum and sushi on mainnet Ethereum might as well be in different galaxies from the perspective of the user. And I was most frequently, jumping between 3 or 4 networks and having that experience used to drive me nuts. And specifically, like, I'm sorry, I love Sushi. It's a wonderful app. They had some issues and like how it worked. It kept wanting you to revert back to the network. It was like, you're on the wrong network. I'm like, no, I know I'm on the right one. I know I've set my RPC on Meta. It was so frustrating and dealing with that for months. I just kind of became obsessed. And then, total serendipity, a friend of mine calls and says, there's an opportunity to work on an interoperability project. And she like explains the story, and she says there's a couple of brilliant engineers who previously worked on Celo. I'm getting Zaki Manyan, who is a big Cosmos contributor, and we're all going to start spending time on this. Like, what do you think? And I'm like, listen, drop whatever you're doing. You should just go work on this. Quit everything. Sounds like the most interesting thing in the world. Just go work on it. And like, I can spend some time on it, but I can't really I'm pot committed here. Like I can't. Um, and I start spending time with this group, and like the thing that later on will become hyperlane. And suddenly, it was before you know it, I was like, oh my God, this is all I could think about. There's nothing else I want to do. And a
So
little
how
bit
big's your
after that,
team?
it's still small. We're still under 10. So there's 9 of us.
That's perfect size.
Yeah, we like it. We really like being, kind of like a small elite unit. I previously, so I'm Israeli. I served in the IDF, so I'd been on a part of some like really good small teams. As I mentioned before, big sports fan, right? And I love this idea of like I want to build like the 96 Bulls, right? Like a small elite group. Everyone has a desire to be excellent. And so we are small. We're gonna grow, but not humongously. And so we'll likely always be a team. When people hear about how many people are here, they'll be like, wow, that's small. And I'll be like, yeah, that's okay.
Yeah. Super cool. All right. Well, yeah, let's just I guess we can just jump into how you guys work. So the first thing, what would be an example you guys, I guess, are trying to solve? So like what now are you guys are trying to connect, say, Ethereum and Avalanche? Is it any EVM chains? Is it Cosmos? What's the
Great
thing that you
question.
guys are doing?
So we can talk about like the meta, the high level, and
Okay,
then the more like, tactical, like what are we actually doing today? So
sure.
high level, we want to connect every blockchain environment, really any smart contract environment. Forget even the word blockchain. So if you are recording state and you have smart contracts that manipulate and read that state, we want to connect those things. And whether that is, and the reason why I just try and keep it ambiguous as an environment, because I see minimal distinctions insofar as like this ability to read and manipulate state between what you'd think of as a bona fide layer one, as a rollup, as an app chain, and what I've started to call like app specific rollups. It's a terrible name, but I think people
Sure.
get my drift.
Yeah.
Right? Like I'm convinced that there are going to be many, many, many chains. In fact, the world of like a crypto in which there are not many chains, just as an industry that did not grow enough, did not meet, the sum of our ambitions. And it's not an industry I'm not interested in building for that scenario because things just didn't work out. So we're trying to build for like the successful version of crypto. And if we don't get there, it's fine. So there's going to be a lot of chains in this world. What do they look like? Well, they lie somewhere on some spectrum from like on one end, everything's super heterogeneous. So every environment is very distinct. Like imagine we have Ethereum heading EVM chains. We have like Cosm Wazoo chains. We have like Solana VM chains. We have Move-based chains like Sui and Aptos, which even though they're based on Move, they're both like pretty different environments, and everything's super, super different. And then on the other side of that spectrum, there's one environment, and it's the hub for like many such chains. And it might look like, Ethereum with a bajillion rollups. It might look like, Cosmos with a million app chains. I personally think we're going to lie somewhere on that spectrum that is between the center and the hub part, where we'll have a number of large hubs and many both like generalized and app specific rollups or app chains. So we want to connect all of those, and we want to connect those with as flexible set of rules as possible. Whereas something like IBC, it's incredible, but it does have a very rigid set of rules for like what is acceptable. Similarly, Polkadot with the collator and the parachains, an even more restrictive set of rules than the IBC set of rules.
Well, maybe you can explain IBC and rip on it at the end, and we can just that can be fun.
So yeah, so we'll say first, like we have a lot of roots coming from the IBC design. We think it is if we lived in a world where everyone was building according to that rule set, IBC would be the best way to do interoperability. Like the set of trade-offs that it lands on is really good. One part that we just don't like is like it's too rigid, and we now have evidence that people want to build outside of this rule set, right? Majority of blockchains would not support IBC right now. So IBC uses like you have these zones and hubs, and we use relayers to communicate information between the app chains that lay, think of them as like edges on this network. Excuse me. And the key, like what makes this rigid is that every edge on this network needs to be somewhere where we can have light client verification. And that is a pretty stringent requirement. So if you have fast finality and you have light client verification, you can be an IBC chain. And we can use different sets, like we can use these open source relayers, and we can have them communicate information between the chains. This allows us to have a very good grasp over the consensus of any sending chain. And like as the destination chain for any sending chain, we feel very, very good about what's being relayed. And we can also have control over which chains we can communicate with. So we looked at that design. We're like, this is excellent, but like, how do we make it less rigid? Like, what are the principles we want to keep? We want to keep the open source relay. We want to keep the control over, like, for every edge, which which other edges do I want to have a link to? And what I don't want is I don't want to be limited to only fast finality and to only light client verified chains. And from that came what is now hyperlane.
All right. Well, yeah. Well, let's get started. I'll just pick two random chains. You can tell me how they'll kind of connect. So we'll do, I don't know, like two that don't sort of have native data bridges, by their validators. Like, how about like we'll do like Avalanche and Ethereum. So
perfect.
It'll be like Avalanche C chain. So you have like they're two Ethereums that don't talk to each other, basically.
Yeah.
So sorry, Avalanche.
Yeah. Accurate description. I'm sorry, Google, if you're listening. We'll get coffee sometime.
This will be C chain, so this will be Ava, this will be Ethereum, and then they want to talk to each other. So they want
right. How do they do it?
How do they do this? So first thing would be so I guess we'll have user over here, and let's say he wants to get token balances from a smart contract. Like, is this a good example? Like, he wants to be able to read token balances from people who hold a token over on that.
Perfect example.
Okay.
Perfect example.
So and he
that's actually like a specific feature that we implemented with Hyperlane, so we can go through that. But so more generally,
okay,
Hyperlane uses we call them mailboxes because that's what they do. They deliver information, and they live on each environment that we want to support. So in this case, we would have a mailbox on ETH and a mailbox on AVA.
So is that a mailbox?
This is an excellent illustration of a mailbox.
That's good. Eh?
Yeah, it's excellent. This is
all right, so we put mailboxes over on each chain.
Yep.
And then, so what are mailboxes?
What are mailboxes? Mailboxes are a pretty basic set of contracts that handle the sending and receiving of information. So they have a function to send the information to a different mailbox on another chain. We call it dispatch. And then it has process, which is, as it sounds like, it processes the incoming messages from other mailboxes. And that is where we verify the signatures to ensure that the message is valid. So in between these two mailboxes are two sets of agents that are critical. One of them lives totally on chain. These are our validators. The validators.
Validators would be on each chain, right?
Each chain, yes. And importantly, they are distinct. So the set of validators who are validating the outbox, like the outgoing messages for Avalanche, do not need to be the same as the ones who are doing it for Ethereum. And they both keep...
But they could be, right?
They could be, absolutely. That's 100% right. And in many cases, they will be because, you're already, the operational burden of running a hyperlane node is incredibly light by design. Think of it like as a sidecar to an existing validator that you're running, because all you need to do is just verify that the state that you're about to communicate is it is authentic. It is the state that you're getting when you read a certain block height from your node, and then you just need to write a signature attesting to that state. And so they do not have to be identical. They each keep their. Sorry, go ahead.
So just to break it down how it works. So AVA validators would basically they would grab with the block head, the entire block of Avalanche, and they would somehow.
So actually what they look at, so when that message goes into the inbox, it gets added to an incremental Merkle tree within that contract.
Okay.
And now as the validator,
so is it a specific message? Do you have to
message? Yeah.
It's a specific message that so this, let's say the user over here, he would off chain, I guess, ask the validators, can you sign a message?
Oh no, you do it. You actually do it. You do it all on chain. So
he would request it over here on ETH.
Yeah, he calls dispatch on ETH.
Dispatch, okay. And then
And now validators are always observing
so
the ETH
the AVA
outbox.
validators are observing this one.
No, sorry. ETH validators are observing that.
ETH
And
validators
then
are okay.
they are like, they see that, like, if that message is basically included in a finalized block, now it looks good. There's no reason to contest this state. It is
No, so I mean, so
accepted as
this is the guy who wants the data from Avalanche. Is he the one that
yes,
calls dispatch?
yes,
So he says like, I want token balances on Avalanche, right?
yep. And
That's
so
what
what he
he
would, and then he could either like custom have, like he could set custom logic
okay,
for Avalanche state,
and he
or
would
he could
put
like
all that
use
in dispatch, right?
yes. Now, when that message arrives on Avalanche,
Okay,
we
so
need to
these guys
look at
would
this.
push it over to Avalanche, right?
There is another set of agents, the relayer. This one
Okay.
does not involve a stake. All they do, it's an open source and permissionless role. We have the binaries for a relayer are already on the Hyperlane GitHub.
So basically,
And
if a message gets validated here, they push it over there, right?
exactly.
Yeah.
They push it then through process. Process would look at the signatures that were provided by the ETH validators.
Okay.
If there's a sufficient amount of signatures for quorum, all the signatures are valid, that message will get processed. And now there's an important element of like the innovation that Hyperlane brings that will happen, but we'll touch on that later. So for now, just remember something called sovereign consensus would come into play right now, but we'll expand on it as soon as we're done with this example, because I don't want to complicate things a bit too much. Yes. So now we need to look into those balances, and we need to send them over.
Look into the balances, right?
Basically like the Hyperlane contract would. And now there's another message they need to look into, like look that that's valid. They would confirm if everything looks okay. They would confirm it. They set their signatures, and now relayer could be the same one or a different relayer performs that same action, returning the balances to our guy back on ETH.
Okay, so get data, like whenever he calls dispatch, it would be like a function call over here.
Exactly.
So it's not just like asking for return all block headers or something like that. It's like return a function call, a read function. The contract would validate it, get the data, and then basically publish it, and the relayers would grab it and push it back.
Exactly. Yeah.
Right. So perfect.
And so that's like the type of action we'd call we call it a callback.
And then this would be a callback. And then okay. Cool.
Now generally speaking, we design Hyperlane to be a developer tool where developers connect contracts between chains. So you would have your contracts that are just your app, again, to like go back to that sushi example. And you would also implement some logic about how to receive those messages. So you could imagine like the end user interacting with your contract, which interacts with the Hyperlane mailboxes.
He would have his DApp over here, and it would
exactly.
Does callback, when they call callback, does it kick off a function here, or would he then have to call a read?
No, he wouldn't have to call a read. So like depending on how the developer architected it,
the relayers
fairly easy
calling his DApp for him and pushing it.
Yep, exactly.
Okay.
Yeah, the second process, when the process happens back on what was our origin, it moves back to its destination. And you can have contracts that basically are what we call handlers, and handlers help implement the routing logic.
And he would put like which handler contract he wants to call on the callback when he calls dispatch.
Exactly.
Yep.
Exactly. Yeah. And what this lets you do is go back to what we talked about earlier with IBC. You want to have control over which chains you connect with. So the Hyperlane network will be a network of many different blockchains and different environments, but you might not want to connect to all of them. There might be some John chain by some,
right,
crazy fellow there, and you might want nothing to do with it. And so, again, we are trying to build a modular interoperability platform, and with that, we want to give apps the ability to control which chains they communicate with. If you want everybody, by all means. If you want a superset of our network, by all means. If you want a subset, you should have that control. Crypto has always been about sovereignty. We have to give it back to you, right? And so that's one of the things that the handler contracts allow you. What they also allow is for sovereign consensus, the thing that we think is really what sets Hyperlane apart. With every interoperability platform, you're kind of opting in to their security model, right? Like there's a very clever group of individuals who have come together to build the thing they've built. And there's like, we have solved the problems with security. And when you're an app that uses their contracts, or even a user that you context independent, you always get the same security model from them, and you hope that it works. And in the day where like that security model becomes obsolete because of industry innovation, like maybe you have to switch, God knows what you'll have to do, but it's an unpleasant place to be. So again, going back to this idea of trying to build the modular interoperability platform, we wanted to separate this act of passing the information, executing the functions, doing the things you want to do, and how you secure those. And so securing those, everyone gets like the validator part for free, but with sovereign consensus, you get the added ability to configure how you want to process messages on an app level. So the rules that Nick implements do not influence my app, and vice versa.
So like in the handler contract here, so like this will be the handler, you would have, this is like the sovereign consensus. And what exactly do you specify there? So like you specify, like I know you said the security model, but is it like which validators or which relayers? Or
you're really on the right track.
Yep.
You're very much on the right track. So that is one of the things that it allows you to specify. It allows you to pick a subset of signers that will be required, without which there is no messages cannot be processed.
Okay.
You can imagine requiring your own signer, a multi-sig from your community, someone you just trust because they're a trusted actor. What this will allow you to do is to isolate failures, such that a broad failure of the validator set, which I would include validator collusion in this definition of broad validator failure.
So like you could
isolate yourself from that.
A minimum set of validators, right? You could
say, where you could say like we must have these signatures to constitute a valid message processing, where we don't care if 100 validators say X. If this one does not say X, no dice. But you can also include more complex logic. So we introduce these things, we call them interchain security models, ISMs. Think of those as like off-the-shelf security modules that you can incorporate. One of them is specify your own signer or signers. One of them is introduce an optimistic model, where for certain types of messages, we don't want to process them right away. We don't care that the signatures look all valid. We introduce a delay. During that delay, we specify either everybody or like specific addresses can submit a veto or a fraud proof to prevent the transaction from being processed. And you can imagine like cases where this might be useful, where say we're dealing with a lending app. If someone is just about to borrow, let's say less than 10 basis points of your available capacity, okay, have it go through the regular model, right? That's probably going to be a standard type transaction. You do many of them a day. Just have it go through the fast path. But if someone's about to withdraw 50, 60, maybe 100% of your capacity of the value of a contract, we might want to delay that. Similarly, if we were talking about any transfer of assets, I liken it to going to the bank and trying to withdraw just a few dollars. They barely ask for your PIN number. They do out of precaution, but they barely care. And if you try and withdraw any meaningful part of your account, or really any five-figure amount, they start asking a lot of questions. Try and get your whole account out, they're going to give you a rectal. Like, and generally, people are kind of okay with this idea of context-based security practices. And so the key thing that Cybermetrics lets you do, it lets you introduce context-based security. So you could say, these transactions go through nothing special. They just get the validators. These transactions, however, should go through the optimistic model. And these transactions, maybe we want both an optimistic model and we want to make sure that our validator is included in the set. So the idea is that a system failure from hyperlane should not mean the end of your app, because it has meant the end of your app in every previous case, right? A failure of security in the platform that you're using to enable your app generally has meant a failure of your app, and it's time to end that.
Well, it's tough. I mean, this is part of the issue with like oracles in general. Like
100%.
anytime there's like, because like we have those issues too. Like you can, like anytime you're talking about upgradability of an oracle or like reliability, like you can the end user can always just own their own security and have the ability to shut off the oracle and change it. But then then you have another attack vector as far as them shutting off and killing your oracle.
Yeah.
So that's like, yeah, it's tough. But no, it's
yeah.
cool.
So the key part here is that we don't like you get control over what your app accepts, not over what gets sent. So like you could send the malicious stuff all day. It's just not going to get processed. So the system doesn't prevent anyone from sending anything. That basically
it might get processed if you use the base one, right?
Yes, 100%. Yes. So
that's like, so yeah, can we loop back? So like I would love to talk more about, so like the validators. So these are validators on each. Who's allowed to be a validator? What sort of, do they stake?
They stake.
Okay, so they stake. Do you guys have a token they stake?
It's not, there is no token yet, but so basically what we're thinking is incorporating different assets. So probably like restaking of the native asset on that given chain. And maybe we might incorporate our asset, TBD on that. But the idea is that they have to stake.
If I run a validator, do I qualify for an airdrop? All right, you heard it here first, folks.
But the important part, and this is why we separated the validators into individual sets that live on every chain. If you have that, if you have the stake and the message being validated living on the same chain, then you can have verifiable fraud proofs.
Well, it has to be. Didn't, I mean, always. Yeah.
You'd be surprised. Some of these systems.
Trust me, I know they don't. Yes, I know.
Oh, okay.
Yeah.
Yeah. So let's say for the audience sake, right? Like, why should you have the stake on the same place that you're validating the messages? Because it's the only way to know for certain, like, that you can punish misbehavior, right? Like if someone is misbehaving, that message is going to get added into the next block and that signature will be there, and like we'll see what the validator did. And as long as their stake is there, we can permissionlessly, without needing anything, trigger a slashing event. And we can make sure we always attach a cost to fraud. You are not getting away with fraud. That cost might not be high enough for certain incidents of fraud. And that's why sovereign consensus is so necessary. But that cost is above zero and is always chargeable. So, whereas you could have the stake living on another chain. And then how do you slash it? The same validators that are misbehaving need to communicate this event that is going to slash one of them. And what do you do if some of them, or like more than a third of them, are actually colluding together, right? So they're supposed to communicate the information that is leading to them all getting slashed. So you can only slash them in a permissioned way, and now you're opening up a whole can of worms. So we really like having verifiable fraud proofs and
Well, on
permissionless
this, so
flashing.
like, what is a verifiable fraud proof though? Because that's what's tough about here. You know, like let's say somebody pushes bad data on chain. Okay,
Yes. So
how
our
do they
case is
get
very
slashed?
great question. So we define fraud as two things. You either sign the message where there is no, we would not, if we looked through the, excuse me, if we looked through the history of blocks, we will not find it included in any block. So you signed something that did not get finalized, that did not get
But I mean,
included.
there's like, well, I mean, like you're signing, like, what are you signing? You know, like
You're signing the root of the Merkle tree of the mailbox contract.
the root of the
And so,
merge, and then you're pushing it over here. So like they're right.
yes.
So they would push it over here, and then somebody would see, okay, so there's somebody over on the ETH chain pushed a bad.
Yeah, but also
right?
everyone on ETH sees what was pushed,
Okay.
right? So everyone on ETH can see, wait a second, that thing that you sign, it says that there's a message from Nick in there. But if I just look at the block that it's supposed to be in,
They're
there's
only
nothing from Nick.
right. They're only signing things from the ETH chain, so it's not.
Yeah.
Yeah.
Now, so signing something that isn't there, meaning it's not present in any block, that's fraud. The other incidents of fraud, not signing something that is there. So effectively like censoring.
Okay.
All right. So if hey, I can look at the last block and I see Nick's message clear as day. But the validators who didn't sign it, they are now open to slashing.
Okay.
And the way that we trigger that is you basically would either show, hey, here's the signature, and here's the block it's supposed to be in. There's nothing in there, slashed, or here's the message. Here's the validator, because the validators all maintain their keys. This key did not submit a signature for this message, and it's been,
right,
more than enough time, right? Like we'll probably give them right now with like, yeah, you need to give them some amount of time, right? Like it can't be that they have 7 seconds or they're committing fraud.
well, I mean,
But after that,
the one risk I see like on Ethereum would be like if they sign a message and then the state reverts, you have some sort of fork or something.
Reorgs
Right.
would lead to flashing 100%. And on account of that, validators generally have to make their own decision about, well, hyperlane does provide like guidelines, but they obviously at the end of the day, it's their capital, it's their money at risk, and so they have to make educated decisions about what is the finality time that they should be waiting before submitting a signature, and they will never be slashed before like what is considered the general finality time for that chain.
Okay. So you would have to probably just configure that per chain somehow.
Yep. So right now, if you went to the Hyperlane documentation, you'd see in the validator section, like the recommended finality times, as that came from a mix of professional validator companies like Figment and Staked and I guess Coinbase Cloud, now formerly Bison Trails, but also direct recommendations from other infrastructure providers who are, have a good sense of this. And in some cases, the direct recommendations of the teams of those, of those layer ones themselves. But it is important to note. And so really you could think of like, what's the speed of Hyperlane? Well, Hyperlane operates at what I'd call like the speed of light for blockchains. And that limit is finality time.
Yep.
Like you do not want to exceed, you can, but you have to be understand that now you're incorporating another major element of risk. And if you're comfortable taking that risk for a fee or for any reason, by all means, but it's finality time on sender and 1 block on the receiver.
Cool. Okay. So now my other question. So the message, we'll get back to these guys later. So the message goes over here and gets pushed into process and validate. How does this contract know who the validators are?
It doesn't, and it doesn't need to.
Okay, please explain.
Yeah. So it basically, like, at that point, what it receives, it knows of. So we keep like a ledger of the addresses through what we call a connection manager. And back to that point earlier of like which which contracts should I connect with? And so as a hyperlane as an app that leverages hyperlane, you're you're using a connection manager. It could be yours, it could be someone else's, it could be like the default one. And the connection manager basically has the registry of all the inboxes that it wants to connect with. And so you know that you're using a certain connection manager, and presumably your usage of that specific connection manager is an acceptance of the validators who are going to send you those messages. And so let's say if you don't trust the validators on John Chain, then you would use the connection manager that excludes John Chain.
But like in this case, like let's say you spin up a connection manager and you're running it, you would then be you would be in charge of placing those guys' validators addresses in here.
Yes.
Okay, so it would probably be like a centralized multi-sig way of doing that, I'm guessing, or
no, like
what would be the way?
So it's basically it's kind of
go
up
back
to
to like
you.
sovereign consensus. They would basically have to like. So like this inbox though would have a connection manager. Is that how it would work?
There are connection managers that the inbox looks at, and the app decides which one they're going to use.
Okay, so this goes back to basically the app would have to determine
Yes.
which
Yeah.
validators.
So like they're
So
yeah. So think of like
okay.
the base connection managers. Those are the ones that currently include all chains. But so you can, Nick can basically copy that and say, I don't know how I feel about this chain. I don't want to name any. I don't know how I feel about that one. And so my connection manager basically now excludes the chains I don't want to communicate with, and it coexists with the other one, right? So like your decision.
Even in this case, like regardless of whether it excludes the other chains, it would just be like, like let's say we're over here, and then there's 3 validators starting out. You update those 3 validators. 5 new validators come on board over here. They stake a bunch of money and they want to be honest and start signing messages for you, right? You would then go and update this and then.
Oh, sorry. So like the connection manager does not need to be updated for the addresses of validators. It just knows the addresses of the mailbox. The mailboxes know the validators.
But the connection manager is over here on Ava.
It
would just, it knows the validators, it knows the inbox address over here.
Yes.
Okay. So
yeah, but let me ask you this. What do you think is the inherent benefit of them knowing, like on Ava directly, who are the validators on each?
Well, I'm just wondering how you validate it then. Like to say like, oh, these came from staked validators, because that's what you want to check.
So we're just looking at so you're just looking at the signatures. You're just validating their signatures, basically.
You're just saying these are
these signatures.
You don't even know if they're staked over here.
That's right. Yeah.
Okay. That would be punished over here by the sovereign consensus. This guy would make sure that they're staked guys, right?
Exactly. Yeah.
Okay.
But those are good questions.
Yeah. No, I'm just trying to see like where we make sure they're staked and then would slash.
Yeah.
But I guess that's
yeah, everything relating to confirming that your stake is there, because as you know, right, like all of this is just, and everything in interoperability is just different manifestations of the Oracle problem. And
completely.
you've worked on it as long as anybody, right? Like people try to obscure this fact and they like don't talk about it, but we're just dealing with narrowly purposed oracles, right? So if like
completely,
Chainlink or Teller are more like generalized, these are just all they do is like they're oracles for blockchain state, but all the issues that come with oracleizing information are still the same. And so in the case of Hyperlane, we're oracleizing contract state, and if we want to know what it is on Ava from ETH, then we don't have a good way to do that. And so we want to design the system in a way where like the things we need to validate really only pertain to something we can have very good assurances on without relying on any other party. And so the stake lives on the same chain, the slashing happens on the same chain, because those are things we don't need any external information about. We can view it right then and there. And we wouldn't like, yes, someone on Ava can actually use the hyperlane system to initiate a slashing event for a misbehaving validator on ETH, but they don't have to do it that way. And they could just as well, someone natively on ETH can just send that slashing transaction. Because like, and that is where that core information lives. And that's where we have really, really good certainty about that information. Once you start losing certainty about that type of information, now you have consensus issues. And of course, those can still happen, but like, we got bigger problems when that's the case.
Well, I think one thing you could do is, like basically like the hard part for the user would be like, how do you update the validator set in your own smart contract and the sovereign consensus? So like, you should use Teller. You could have like,
All right.
you could have like, say, Teller reports the honest validators, and then like, and then the app could not worry about it or something.
Yeah,
Yeah.
I like that.
So
I'm
something
bring it
you
up in
would
the
almost
next
like want
engineering
another.
meeting.
You would want like you need like a trusted third party basically if you don't want to own it in your own dApp. So either you use a trusted third party, or you come up with some decentralized scheme like Teller or something to handle it. But yeah. Okay. I'm going to say last questions, but it's almost certainly not. Relayers. Who are these guys? Where
they can be anybody.
Are they staked?
No, they are not staked.
So
they have a pretty simple role. They just observe mailboxes for outbound messages, and then they initiate process on the relevant mailboxes.
And then they call callback, right?
Well, so what they basically like, when they don't need to call it, they just like initiate another process.
Well, somebody calls process or callback, right?
Yes. So so like, think of a relay as generally like chain. Yes, it could be the same one, it could be a different one, but the way that we think of relayers is as a form of miners. You propose a certain fee that'll go to the relayers. It could be zero, but it's your choice of whether or not they'll go through the trouble of processing your messages.
But what's to prevent a malicious party from becoming a relayer?
Nothing. The thing is, then you just need to make sure they can't really do anything.
So like,
and all that relayer can do is like,
well, he could call callback and push it to your contract, right? He says like you called the token balance for this guy, and it's going to mint tokens over here. So he calls, okay, he says like, he lies and says it's actually 1 million. The guy has 1 million tokens, and it pushes to your contract.
Oh, they have no control. Or right, so like if they try to alter something, right, then like that Merkle root is not going to be valid anymore. And so they can't really alter
from over here, but you're over here, right? But you need the Merkle root to be valid over here, right?
Yes.
So like, what would I guess the way I would see it, if I was one of them, then I would manipulate it, is I would fork this whole chain, the mainnet chain. I would then go stake a bunch of validators and sign it, and then the relayers would push back like what looks like a good
do like a sort of replay.
Like what would prevent that?
Great question. Okay. I can't go super into the weeds of what prevents that, but I can tell you like high level. It's basically like implementing certain identifiers that like unique nonces, and where like,
would the dApp have to do that, or
Hyperlane does it for the dApp?
Hyperlane does that. Okay.
Yeah, but that's an excellent question, because yes, this is like a sort of
That's the
like
hard part,
Ocean's
yeah.
11, a sort of like Ocean's 11 where you like build another casino side by side with it, and
Yep.
you like try to pull off a heist that way. We've definitely thought about it, and it's not outlandish enough. Like someone will do that.
I'll do it.
And so
Yeah.
someone's gonna do it. Someone's for sure gonna do it. And so we had to design. I'm not smart enough to go into like the full intricacies of
Well, you can send
how
me the
those
link
protect.
afterwards that explains it in your doc or
Totally.
something, and then I'll post it. Yeah, because I think that would be the risk if, with like any real, like obviously if you had a trusted
Yeah.
or staked
Yeah. Yeah.
relayer
Yeah.
set, you could do it. But now like if it's anyone, they would come in, just basically fork the chain and push it, and then it could appear valid.
Yeah. Yeah. It's like basically how do you prevent something that genuinely isn't valid from appearing valid? Because that's what happened in the most recent, I think it's still the most recent interoperability related incident where about 190 million were lost from the bridge. The proving system had some faulty implementation
Was this
to where
Nomad or
you said the name, I didn't say it. But yes, the
no? I mean
Nomad
we
incident.
like the Nomad guys. They're cool guys.
Yeah, they're excellent people. This is heartbreaking for anyone, and like
Yeah,
these incidents really suck because they're just a reminder of like how unforgiving and brutal crypto is. Like bigger mistakes happen every day at far
sure.
larger companies, but like oh it happens at Google and like G Drive, like Drive doesn't work as well, or like you lose a file. It happens in crypto and you're out 9 figures, right? Like it's
Yeah,
crypto is super unforgiving. But in that case, basically like anything passed through looked valid. And so like someone didn't have to go through the trouble of what you said, right? Like they didn't have to rebuild a casino side by side, but basically
yeah.
everything they entered looked valid. And so that's the biggest concern in any one of these systems. Like, how do you make sure that only something that is valid gets processed? Because if not, then you've basically input, so people always think that like they kind of talk about like, oh, what could you do in a 51 attack on a layer? Not that much. You can't do that much, right? Like you can't like move the balances around. But
Yeah.
in an interoperability network, in an Oracle network, there's a shit ton that you could do. Everyone on the other side of your information is totally reliant on the system for whatever you give it, it takes as given. And so that's why, like beyond the like signature safeguards and the verification safeguards, we wanted to introduce something like sovereign consensus to just like if the worst happened, if there is a way to like get through all of these things, like how do you isolate yourself? Like um because these systems are terrifying in a way. And like I liken it a lot to the crypto equivalent to do this at scale and to do this safely. It's kind of like the crypto version of going to the moon. And there were 13 Apollos before they got there. Most of the Apollos they did not make it. Some they don't.
Sure. Um, cool. Okay, so other questions I got. This guy, whenever he's calling dispatch, he has to tip, I'm guessing, or pay.
Tip pay, yeah. I think tip is more appropriate because
Sure.
it's not like it could be processed without it. Just like, someone might serve you, deliver your food without a tip, but like it's less likely.
So okay, and then I mean, how much is it? Who is he paying? He has to pay.
He's paying, so he's putting up basically, he's kind of like putting up money for grabs, and
Yeah.
he's paying it to the relayer who will actually process his message.
So
Uh,
so do these guys get paid too?
those guys earn fees based on like their staking service, and may earn emissions of like standard
Emissions of
proof
some
of stake stuff.
token to be dropped.
Some
Yeah.
some
Okay.
imaginary asset. I don't
So
know.
basically, but the tip
Uh,
is basically it's
the
to pay
tip primarily is for
the gas of
relayers.
this
Yeah.
piece, right?
Yes, it's to pay. Well, there's two pieces of gas, right? Because there's like the dispatch and
The
the
gas over
process.
there.
Yeah, and it's to make sure that you don't have to. So like the relayers help you deal with destination gas, because what good is an interoperability system where the sender is required to have destination gas? That's a pain in the ass.
Yeah, but
So
I mean, this guy
that's
could, like this is similar to like the Teller system too. Like this guy could just be his own relayer. Like he could do
100%.
and then just
Not only
yeah.
can they be their own where we are very much like, at least our team, right? Is planning to offer up a script that any application developer can add to their UIs, and just allow the senders, that their actual users, to be their own relayer. Because like, relaying is uh, not that complex, like different people act like it's more, but it really isn't. And so you can have total sovereignty where like the sender of the message is the one actually relaying it, because relaying is as simple as it sounds.
I'm still on like gallery view, so people couldn't see me.
You're good, yeah.
But we can pin it for at the end. I'll take a picture of it and then post it up. But yeah, people can see the full board. I know I wrote small.
Yeah.
But yeah, this is I guess what did I know we're approaching the hour. What did I forget? What else can we go over? Anything?
I guess we went over sovereign consensus. I think that's like the most important thing for mine to go over.
I mean, are these contracts upgradable? I have to ask.
They are right now. We are still
Okay.
in main and alpha, but as we transition to our future versions, which are going to be like a bit more feature complete, they will not be. And so at that point, the intent is to the expectation and the intent is for validators to always support the most recent and the current versions, but no more than that, because they're going to look like different contracts from then on out. Right now, where hyperlane is, there's, let's say, a little under 24 applications that are working with it in various stages, and only a handful of them are live. And so it feels like okay to still be in that upgradable contract.
Sure.
As soon as there's real stakes, and like there are stakes now because a couple of them are live, but right now it feels better than not, because you can, yes, the systems are audited, but like, I don't know your feelings about audits. I feel like they are a nice to have, but they are certainly not. I don't sleep better at night because we were audited.
No.
My level of concern is just as high, even if we were audited by the Michael Jordan of auditing.
Yeah, the best audit is just throw $10,000 in your smart contract and push it live.
Yeah, exactly.
If you're live for 6 months and the money hasn't been stolen, that's
Yeah.
by far the best audit you could possibly
Exactly. Yeah. We will have like these bounty programs that are going live with Unify pretty soon. Like, I'll feel better about those, but I'm not assuaged by like year 5 of operating without any issues. I'll feel a little bit better. But we're gonna basically keep one of those signs out, like this many days without an accident, and hope that it never resets.
For sure. All right, well here I'll go back to gallery and we can close it up. I think the one question I like to ask,
Yeah, of course.
if you could go back and start it over again, what mistakes did you make, or what was surprising when you were building this, and lessons did you learn?
That's a really good question. I think, and my co-founders might disagree, but
Perfect.
I certainly feel that, so there are certain things that, call it intuition, call it like previous experience, or just like, we are going to need these, and we're going to need them day one, and their presence or lack thereof will make a real difference. If they're not there, people will wish they were there. They might not know the words to say that they were there, but the things they will ask for, the areas of need we'll see. And there's at least one of those things where we knew about it. Like, I really knew about it, and we waited. Cyberlane's been live for a couple months, and only now is this thing like basically being launched, where we knew like you would have talked to me in January, and I would have put that as like one of the bare bones requirements, but there was no evidence for it beyond like this, strong feeling that it's going to be very required. And I would say like sometimes when you have those, especially when like, I've been in crypto long enough, right? Like I've worked with dozens of companies, so I just trusting those, and we've since basically trusted a lot of those types of intuitions. Um, so that was something I wish we'd done. It hasn't like had a big negative impact, but still I think about it, and
All
I'm
right.
getting upset just thinking about it now.
We don't need to dig any deeper. We don't need to.
Yeah. What about what is your answer to that question?
Oh, I got like a million. I mean, yeah, you should go watch the Teller episode. We get into that a little
Oh
bit.
shit. All right.
Yeah,
I know what I'm
but
doing later.
yeah, no, I had Sasha, former API 3 founder, interviewed me to do the Teller one, and
Nice.
yeah, I mean, you just talked a lot about, you know, launching it, trying to get it out the door, and just trying to get users, and just kind of like following your gut, getting as decentralized as possible, focusing less on the little things, and then same with, you waste a lot of time in crypto and probably startups in general on things that don't work, and it's
Totally. Yeah.
just
So
trying
that's
to,
something
basic
we're
startup advice, just move on, and then it's good, and then same with oracles, like there's always like, there's hard problems and trade-offs, and you just
Mhm.
have to like really just admit try and find where the trade-offs are in your thing, and just be open and honest about it. Like if you're trying to push for decentralization, like don't make a you can't have any of those crux in there. You just got to get rid of them
Yeah.
all, and roll
Yeah.
the dice. Yeah, like and do it as fast as possible, and it's way better. So
Totally.
anyway.
Yeah. If there's anyone who's listening to this and is like, oh, why should I think? Just figure out your niche and just like
Run.
really go all into it. Yeah. Just really
Yeah,
go all into it. And like that is definitely true. I mean, that's what we're trying to do today. It's like, oh, who's like who's really hyperlane for? Well, it's for the the developer that wants to have an experience with their users where their users stop spending so much time interfacing with infrastructure. It's for the developer that cares about like really owning their security in a way that a platform failure does not end them. And like, yeah, there's trade-offs we have to make. Like we can't
for
be
sure.
faster than the finality time on this, like tough. That's like you chose to work with blockchains. Like this is what it means.
Well, I mean, you
Uh,
guys too. Like this is one of those things. Like if you wanted real-time information on the other chain, like this isn't going to do it. I mean, it's just
yeah,
you got to pay gas costs. Like
exactly.
you're gonna, like there's
Yeah,
just this thing called gas costs, so it's gonna blow. If you want real-time updates on it, you'll be
totally.
broke. So yeah, and people do have to realize that, but it's fun times.
Yeah. So the constraints are there, and we all have to deal with them. There's no getting around it. Uh, but this was a lot of fun. I'm really glad we did this. I hope that you found it useful. And
Cool.
if you ever do anything like that again, or if we have like
Well, yeah.
significant enough, there's
Well,
one feature that I could get into that it's like our big thing for this for 2023. So maybe I will come on another time to talk about that
all right.
because
Where
that's
where
gonna.
should people go to find out more? What's the Twitter?
So it's hyperlane underscore XYZ. Our website's hyperlane.xyz. And our docs are docs at hyperlane.xyz.
There you go.
Find it there. Join our Discord. Come with any questions. We are like pretty open, and we will have our first community call at the end of the month. So probably looking like November 27th. But all the details will be in the Discord.
Super cool. And I got somebody brought me back a hyperlane sticker for me to San Francisco. So it's on my laptop now.
Nice. That's great. Well,
Sounds good.
you might if you're interested in a shirt.
All right.
These official. These are the V zeros. They're limited edition. There's only
Where's
200 of them ever
is
made.
that an H? Is that what it's supposed to be?
That's supposed to be the hyperlane H plus an
Okay.
arrow because we're trying, connect between different
That's
things.
good. All right. Super
Yeah,
cool.
this was fun.
Thank you,
Thanks for
John.
doing this.
I'll see you.
Anytime. Have a good.